So hello everyone. Like Kevin says, my name is Marcus Placona. I'm a developer evangelist for a company called Twilio. I know Jessica used all the raising hands credits here, but who knows of Twilio here? Okay, good number. Cool, so I'm a developer evangelist for Twilio, but I'm not going to be talking about Twilio today. I'm going to be talking about something else. But before I start, I'm going to tell you a little story, okay? So it all started a few years ago when I was working with a technology called ColdFusion. Does anyone here know ColdFusion? Oh, wow. Does anyone work with ColdFusion here? Okay. I'm not going to be slagging ColdFusion off, but I just want to say I'm talking Adobe ColdFusion. I'm not talking about these other ColdFusion. So I'm not talking about the science ColdFusion. The size ColdFusion thing. But it all started when I worked for this company and they wanted to migrate whatever we had into .NET. Okay? So as you know, loads of you know ColdFusion or know of it. ColdFusion runs on the JVM, right? So you have Java behind it. ColdFusion creates its classes and everything. And my boss came to me and said, hey, I want to migrate into .NET. And I was looking on Stack Overflow, and I noticed that C# and Java are very similar. So I'm thinking it's not going to take any long for us to actually move from ColdFusion into .NET, which is it really an assumption to make? Like moving from Java into .NET just because the languages are similar? No. Maybe it would be easier for developers to assimilate the languages, but migrating isn't easy at all. In fact, when he told me that, the first thing that came to mind was this. Java is to JavaScript as car is to carpet. They have absolutely nothing in common. They're two different technologies. They run in different environments. They are completely different. I was thinking, okay, so how am I going to do these moves? So I can't just start building a new system and off we go. So how am I going to do this move? The first thing that came to mind was SOA, okay? Just to clarify, when I'm talking about SOA, I'm not talking about Sons of Anarchy, even though it's a great show. You should watch if you haven't. I'm talking about service-oriented architecture, okay? So my idea here was, instead of moving this entire system into one .NET system, I'm just going to build some microservices, as the cool kids call today, and those microservices will help me with this migration. So I can have a microservice for sending emails. I can have a microservice for sending SMS messages. So I could use all those different things. I know some people used this before. Some of you will remember this, although if you're too young, you probably don't. But this actually happened. So this was back when Twitter was using Ruby, and they decided to move on. I've got nothing against Ruby, just saying. But that's what happened. Like, they decided to move because it wasn't performing well. They were using Rails as well, which is, anyway. So other people did that, right? So other people migrated the systems before. So it's possible. It's something that we can do. The solution I found to actually get my applications to talk to each other and to get my applications, specifically my Java and my .NET applications to talk to each other was I'm going to use queues, okay? Because if I have a queue in the middle, I can get my applications to speak on the same language, and great magical things will happen. So I want to tell you a little bit about why queue, okay? Because everybody hates queues, right? Except for the British. British people love queues. Okay, I live in England, and I know British people love queues. And interestingly enough, a few months ago, I was giving a similar presentation to this, and it was actually in Berlin, and I asked, so, does anyone here like queues? And I had a few people raising their hands, and I was like, what? Yeah, so the Germans actually like queues as well. So I hear Germans like queues. It's totally cool. I don't mind. It's OK. Now, what is a queue? So a queue is a semantically precise message that can be passed across. So basically the idea with a queue is you have a message Both your applications understand what this message means, and both your applications know what to do about those messages, okay? These messages can be anything. I'll give you some examples here of how a queue actually works and how applications actually communicate, okay? So I'll start with two cats, right? The first cat goes meow, as a cat would do, and the second cat goes meow. So those are our two cats token here, right? You can, if you replace the cat on the left to the cat on the right, and you use the same technology, you can get the same things, right? So same technology, token, fine. Let's go to dogs. Dogs go woof. Brian then goes, oh, hi, because it's Brian, but it's a dog as well, so you understand it. And that's all fine. Now, we have Java, okay, so I just talked about ColdFusion here, and we have .NET on the other side. So Java goes email.send message. .NET goes like, what? And that's what happens to Java, because they don't talk the same language. They can't speak the same language. So we know this does not work. That doesn't work at all. So let's go back to this example. Let's dissect just this for a little bit. I've got Java on one side, I've got .NET on the other side, and now Java's going email.send message or something. We've seen this doesn't really work, okay? So this breaks. How about we get Java to send .NET a semantically precise message? Semantically precise message being, hey, this is JSON. Is there any language that doesn't really understand JSON? So that's a semantically precise message, right? Some people could say you could use XML here, okay? But the thing about XML is when you use XML, God loves you less, right? So don't use XML. Use JSON here. But yeah, if you want to use XML, it's fine. I wouldn't, but if you want to use XML, anything that your languages can support and understand goes here. You are really talking about messages that tell other systems what to do. And the way it works is your application goes, I want to send an email. There's a queue, and your application will push this message into the queue, as you can see here. So that's your JSON message going into a queue. Okay? Your subscriber, so that's the application on the other side, which in this example is a .NET application. This could be anything else. Your subscriber now goes, hey, I know how to send emails. So do you have any emails for me? And the queue goes, yes, sir, I do have some emails for you. And now my application sends emails. So two different applications talking the same language. So it's almost like now you have a universal language that everyone speaks, and which is not English, but you have a universal language that everyone speaks, and it's all great. Everyone can communicate. Now, let's move on, because what happens now is happy days, okay? So your applications are communicating. Your applications are having fun with each other because they can talk. Great. But you don't just get this. When you use enterprise queues, or when you use queues, I don't like calling it enterprise queues because it sounds so enterprisey. Queues, okay? When you use queues, any kind of queues to get your applications to communicate, you get some other things out of the box as well. So traffic shaping is an example, because now you have multiple applications that know how to send messages and read messages from a queue. I know, I can watch this for a whole day. You have applications that can read messages from a queue, and you have applications that can push messages into a queue. So that's kind of great, isn't it? Because what you have now is you have traffic shaping, and let's be honest, high traffic is good. I've seen many developers coming and saying, oh, my application dies because there was so much traffic. Seriously, dudes, you should be celebrating. Now, don't cry because your application doesn't perform well in high traffic. High traffic is good, okay? When you have something in the middle, when you have a queue, and when you can spin up as many instances of your applications as you need, you get this automatically out of the box, okay? So it's there for you to use. It's there for you to take advantage of. The other thing you get is you get scalability as well. Because, like I said, your applications, you can have as many instances of your applications as you need, okay? So now, scalability is at your fingertips, because you can very much say, hey, my application is super busy now, or my website is super busy now, so I'm going to spin up a few instances of this send email application, or I'm going to spin up a few instances of whatever I'm using here that is actually using a lot of resources on my website. So apps should scale. Okay? There's no excuse here. Even your blog, even if you have a blog that only your mom reads, it should scale, because one time your mom will go and she'll post it on Slashdot or something, and then your blog needs to scale. Okay? Now, the other thing you get is you get isolation. It's funny because I keep on looking at the faces and people they're just like staring at the GIFs like, wow, what's next? Yeah, the GIFs are great. You get isolation here as well, because your applications, they live on their own sandbox. They live on their own place, okay? With isolation comes something that is super important, because you don't want your customers, or you don't want your users to know there's been an error. So with isolation, you get keep your errors away, because errors will happen within the microservices, okay? All you need to do from your website, for example, is you need to make sure that your website can handle it and show a nice message saying, hey, everything is okay, there's nothing going on while you're panicking on the back end, but that's fine, okay? Because now you have these multiple small applications and you have all of them communicating via queues. So that's kind of great. The other thing we get, which I really like personally, is we get cross-platform, okay? So my example originally was I had a Java application and I had a .NET application, and I needed those applications to talk to each other. Java and .NET, they don't talk to each other. But really, you could be using any examples here, anything that can make HTTP requests, or anything that can actually, in queues example, anything that can actually use AMQP, which is a protocol for queues, can do this. And I'm really talking about, I can't really think of a language that doesn't have a library for queuing. You can tell me if you know one, but I can't really think of a language that doesn't have a library for AMQP. Like, I can't really think of a web language that doesn't have HTTP on it, because it doesn't make sense, right? So AMQP is everywhere, and it just works. It's great. You can push messages into a queue, you can read messages from the queue, and that's it. It's super simple, but it works. Right. So I'm really talking about the best tool for the job here. So use whatever you want to use. If you want to use Node.js to get a little module that does something, use Node.js. If you want to use .NET, if you want to use Java, you can use anything you want, because now you don't care about how your applications communicate. Great. So that's one thing off the way. Now, I just want to tell you why you should not queue, okay? Because there's some cases when, you've only had one job. There's some cases when you shouldn't really queue, because queuing will screw you over. Is it permitted to say screw you over? It's probably okay, isn't it? Yeah, everyone is an adult here, so it's fine. Queues will not help you when you need to do payments, for example, right? So you don't want to be buying at Amazon.com, for example, and suddenly Amazon goes, cool, I am going to process your payment, but there's a queue of 6,000 other users who I need to process payments for. Well, what do I do now? So don't break the flow, okay? So that's the one thing I'm saying, don't break the flow. The next thing is, what now? Sorry, did I skip one slide or? No, that's good. The next thing I want to tell you is, what now? So which one will you choose? Because I've talked about queues here, and am I right in assuming that some people didn't even know about queuing, like what queuing systems were? You don't need to raise your hand, it's fine. But there are a few different options for you to do queuing, okay? So one of the options is Microsoft MQ. So Microsoft MQ is great if all you want to do is Microsoft, right? So if all you have is a Visual Basic .NET application and a C# application, then yeah, Microsoft MQ is fine. It works in .NET, comes out of the box, you install it, you have queuing. Fine. RNMQ is a queuing system that works with pretty much any language. So they have wrappers, and they have an API. Well, they actually have an API that makes it work with any language. But notice, OK. That wasn't me. No, that wasn't me, no. OK, should I carry on? Cool. So notice that I said API, right? So RNMQ is an application. Well, it's a web service that lets you use their own queue. But that's an API. What you lose with using an API is you now rely on HTTP. You'll be making HTTP requests to a server, so you're adding latency into your server. Whereas if you're using your own queuing system, then you're not adding any latency because it's just going across the network. There's some latency, but not as much as an HTTP request. Redis, I'm sure most people here know about Redis. Redis is just a database. With queuing, you can really use anything because as long as you can store things and as long as you can pick things out of it, you can use anything. You could use a database. You could use SQL Server if you wanted to. It wouldn't work well, but you could use it. Redis is what some people use because they're lazy. But it's OK. Like if you wanted to use Redis, it's fine. It's a good solution. But it's a bit lazy because you're using your data storage as a queuing system. And Redis is really not built to be a queuing system. The other thing, Java, JMS. So JMS is pretty much the same thing as Microsoft MQ, right? So it only works with JVM applications. If you're building a Java and a Scala application, fine, it will work, but only for JVM applications. Now, my favorite here is RabbitMQ. RabbitMQ is written in Erlang. It's open source. It's free. It's got a massive community behind it, and it's got libraries for pretty much every language you can think of. So they've got Haskell, they've got C#, they've got any mainstream languages you can think of. They've got libraries for. It's normally as easy as just dropping if it's a Java, for example, just dropping a jar into your application, and off you go. You can start using it. Clustering with RabbitMQ is also amazing because all you do is you say, hey, I've got these two servers. You just name them the same thing. Good, you're clustering. Fine. Just a few key takeaways here on what we talked about. The first one is communication is hard. Okay, so communication between different applications is hard. So it's not the easiest thing to do, but you have things like queues, for example, to help you with communication. High traffic is good. Okay, never complain about high traffic. High traffic is amazing. Scale, scale, scale. Always think about scaling your application. It may be very small right now, but it will grow and you will need to scale it. Well, hopefully it will grow and you need to scale it. Stay away from exceptions. If you can actually build applications that handle exceptions themselves, microservices, for example, that handle exceptions themselves, great, do that. Microservices and queuing, they help you with this. So take advantage of it. Coding should be fun. What I'm really saying here is, if you are using different technologies or if you want to use different technologies for your services, go for it. You can do it. Microservices are small enough that if something goes wrong, you can start again. So go for it. And if you're using queues in the middle, you can decide to change what technology you're using really easily, as long as you stick to the same message, as long as you have a semantic message, you can use it. Queues aren't for everyone, like I said. When I say not for everyone, they aren't for every single purpose. Now, this is going to be the end of my talk, but there's one thing I want to ask you to do, if you could, please. I've done this talk a few times before. I just wanted to ask you for some feedback on my talk. All you need to do is, if you can send a text message to one of those two numbers. I know we've got some people from the UK. I know we've got some people from, obviously from Germany. If you can just send a text message to that number, with a number from 1 to 10, 1 being, this was terrible, 10 being, I really like it, I would really appreciate it. Again, my name is Marcus Placona. I'm a developer evangelist for Twilio. It's been a pleasure to be here. I'll be here throughout the conference. If you want to talk to me, please come and talk to me. Thank you very much.